Good morning, everyone. Co-hosted by both the Water2REturn project as well as ELO at the Forum for the Future of Agriculture. My name is Daniel Monteleone, and I'll be introducing the agenda as well as going over the ground rules and letting you know what's to come over the next several hours of fun and education. First, of course, the most important thing is that this event will be recorded. We'll start with introduction to the Water2REturn project will be done by Ms. Pilar Zapata of Bioazul. Following that, nutrition recovery and agronomic products manufacturing by David Haigh of Agoindustrial Kimitec. Next will be environmental assessments by Gulgan Acar of 2B. There will be talking about the impact of an initiative like Water2REturn for the industrial sector, led by Marco de la Feld of UECBV. We'll have a guest project called FERTIMANURE. They also have a nutrient recovery initiative by Laia. Impact of initiative like Water2REturn for the agricultural sector will be myself, Daniel Monteleone. And question, answer, and conclusion will be done by all participants and all presenters. So if you do have any questions throughout the event, let us know. Also, we have a poll for you to answer now, which will be addressed later on in the event. So we'll launch that poll. And then after a little bit, I will introduce Ms. Pilar Zapata, who will introduce, of course, the project. Wonderful. Thank you very much. Pilar, if you would like to introduce this project that the consortium has been working on for many, many years now.
Yes, thank you very Dan. First of all, thanks to you all for attending this conference. I really hope it's of your interest. And I would like to start it by introducing the project itself, what we have been doing and giving a little bit of context because we are joining two sectors that in principle should not be so close each other, but in the end, thanks to the industrial symbiosis, it's possible to find some links. So regarding this context I was talking about, when we were thinking about preparing this project, we as Bioazul, as water engineering company, are quite aware that wastewater is a widely recognized source of nutrients that could be used for further uses, like for example the agricultural sector. At the same time, we are also quite aware about the food industry and most concretely the European slaughtering sector as a very big consumer of water and energy and very big producer of waste and wastewater. This wastewater is full of nutrients, as I was explaining before, and the current approach for treating this wastewater from the slaughterhouses has been traditionally basically treating it to the levels that legislation requires and then dispose it without taking into account these high contents of nutrients and therefore resources. On the other hand, regarding the agricultural sector, the 21st century agriculture is facing quite a lot of problems because it has to feed a population which is growing and it's supposed to reach more than 9 billion people by 2050. And it has to do this with a smaller rural force and in a context of climate change and land limitation and soil degradation. This is in part due to the use of chemical fertilizers because this is like a problem that goes in chain because of the soil degradation, it is needed to use fertilizers, chemical fertilizers in this case, but at the same time, by using these chemical fertilizers, soil is becoming more and more degraded. It is a sector experiencing an unstoppable increase in demand, and this extensive use is problematic because it's associated with the emissions of greenhouse gases, and at the same time, it can cause eutrophication when reaching water bodies. So, by taking these two industries into account and the problems they both present, we thought about water-to-return solution, which we consider is an alternative and more sustainable approach because it faces the environmental problem that slaughtering industry has with regards to the treatment of its wastewater as a market opportunity. At the same time, by adopting this circular economy approach, it's possible not only to treat it, but also to recover nutrients that can be turned into value-added products for the agricultural sector. So, in a nutshell, what is Water2REturn? Water2REturn proposes an integrated solution for treating the wastewater from the slaughterhouses, and at the same time recovering products that may have a high value in the market in the agricultural sector. Therefore, the installations that are present in the slaughterhouses for treating wastewater can be considered as biorefineries. Water2REturn is a project co-financed by the European Commission under its Horizon 2020 program. It's an innovation action that started by July 2017, long time ago, as Dan was mentioning, and it will finalize by the end of this month. So it has a 57 months duration. It has a budget of around 7 million euros, from which nearly 6 million euros are funded by the European Commission. It is coordinated by Bioazul company, which is a technology provider located in Malaga, in the south of Spain, and it comes with a consortium of 15 partners from 8 different European countries with different backgrounds and expertise. So, what is Water2REturn in a nutshell? The technology itself. It comes with 3 treatment lines and it works in cascade. This means that the subproduct obtained from one of the treatment lines is the input for the following treatment line. So we have these 3 treatment lines from which we will obtain 3 secondary raw materials from which we are going to produce 3 agronomic products, plus an energy recovery module. How does this work? The first line with which we work is the water line. In this case, what we do is a wastewater treatment and nutrients recovery process. Wastewater comes directly from the slaughterhouse, and then thanks to an SBR plus a filtration unit, which is composed of microfiltration, ultrafiltration, and reverse osmosis, we are able to treat the wastewater and obtain treated water on the one hand, and on the other hand, a nutrients concentrate, which is a secondary raw material, the first secondary raw material from the project, from which we can manufacture the first agronomic product, which is a biofertilizer. But apart from treated water and the nutrients concentrate, there is a sub-product which if we did not have this kind of approach, it should be disposed, but in this case, we do not dispose it. We use it to feed the following treatment line, which is called the sludge line. This subproduct is sludge, and it is upgraded in the sludge line through a fermentation process with bacillus. It is first sanitized and then fermented. So we obtain a secondary raw material, which is called hydrolyzed sludge. From this hydrolyzed sludge, we will manufacture the second agronomic product, which will be a biostimulant. But we do not only produce this biostimulant, we also feed with this hydrolyzed sludge the following unit, which is the energy recovery module. In this case, what we are going to do is to take this hydrolyzed sludge and go through an anaerobic digestion process, from which we are going to obtain biogas, methane. And it will go afterwards through the cogeneration process, from which we will obtain electricity. From this energy recovery module, there will be CO2 that will be released, but not to the environment. It will go to feed the following treatment line, which is the algae line. In this case, the CO2 released by the energy recovery module is captured, and this fosters the microalgae growth. So what we are going to obtain from here is a microalgae biomass, which is the third secondary raw material from which we are going to manufacture another agronomic product. In this case, also a biostimulant. So which are the key innovations and reasons of the project? So on the one hand, we have a wastewater treatment system that is an integrated system composed of the different treatment lines I have been talking before about. Then 3 secondary raw materials, nutrients concentrate, hydrolyzed sludge, and algal biomass, and then 3 agronomic products free of pathogens and pollutants, which are 1 biofertilizer and 2 biostimulants. So what we are creating, thanks to this project, is a new business model based on circular economy approaches and industrial symbiosis schemes. So we generate this way business opportunities for different involved sectors. On the one hand, wastewater treatment, energy engineering and consultancy companies, manufacturers of fertilizers and biostimulants, and slaughterhouses and the meat industry. Water2REturn demonstrator, where we have been working during all this time. The demonstration site is a real working slaughterhouse called Matadero del Sur. It is located in Salteras, a municipality very close to Seville city in the south of Spain. The demonstrator has a treatment capacity of 50 cubic meters per day, out of the 150 cubic meters per day that the slaughterhouses produces. Why are we treating only 1/3 of the whole flow? Because we are in the middle of a demonstration process. We cannot provide a real scale solution to an end user, but a demonstrator. That is why we are only treating 1/3 of the daily flow, but it could be easily upscalable. This is how it looks like in reality. Apart from, you have seen before these graphs, but now you have here the real image of the system. So you can see there at the bottom, the water line, energy line, sludge line and energy line, and here at the front, the algae line. So we can see them one by one. This is the water line, the SVR, and the other different parts of the system, the filtration unit. Then here we have the fermentation unit, sludge line. And then here we have the energy recovery module with the anaerobic digester. And finally, as I was mentioning before, the algae line. So just to finalize this presentation, which could be the potential clients for this project? We have like 2 very differentiated sectors. On the one hand, those regarding the waste, the production of wastewater, which are in principle the slaughterhouses industry that would be the early adopters because we have already been testing it in a slaughterhouse, and also meat processing industry because the wastewater is quite similar to the one from the slaughterhouses. Concentrations are not the same, obviously, but the kind of water is not so different. And on the other hand, regarding agriculture, we have the agronomic products, distributors, and the agricultural sector, the farmers. As mentioned, it's a modular system to be tailored for further clients according to their needs and expectations. This means we do not have to install all lines in all cases. It depends on what the end user needs and expects. And it's highly replicable because I was mentioning first the slaughtering industry and the meat processing industry, but it's flexible to be adapted to other food industries. So that's all from my side.
Thank you very much, Pilar. Wonderful presentation. And we did see the 2 different groups that the project is addressed to. Of course, we'll have those presentations later on. For now, we are going to nutrient recovery and agronomic products manufacturing. David, welcome. David, it looks like you might still be on mute. My apologies.
Can you see it? The
We can see the
presentation?
presentation and we can hear you clearly.
Okay, perfect. I'm going to talk about the nutrient recovery and agronomic product manufacturing. Here it is. As Pilar already introduced to you, we have 3 different lines, and we expected to have 3 different products. One which comes from the water line, other that come from the slat line, and the final one that comes from the Haigh line. Here you can see both the 3 of them. The one is called AP1, that comes from the water that is refused from the filtration system, and AP2, which is a formulation of the slat line, and AP3. Sorry, here is a mistake. It's AP3, the final one. The one that's come from the Haigh line, that is a formulation also. It's not just the Haigh biomass, but formulation. At the very beginning, we wanted to work with this AP1 because it was supposed to have a very high amount of nitrogen and phosphorus. But the truth is that the amount of nitrogen and phosphorus was not so good. So we rethink this product in order to use it like inside the 0 kilometers policy. We wanted to try it in the field that surround the slaughterhouse, but unfortunately it was not possible because there is a river nearby, and they didn't get the administration licenses to dump it, to use it in the field. But as I will introduce you later, we test it in another crops. But the problem with this AP1 is that the richness of nitrogen and phosphorus is not so good. It's mostly water, so it cannot be considered an economical product, because being mostly water, that means that you are transporting and you are trying to sell water. So this is the reason, because it is a useful product because it's not very much rich. It's not highly rich in nitrogen, but it contains nitrogen, so we can use it. It can be used to replace some chemical nitrogen, but it's not an economical product for us, for Kimitec. Here is the process we follow with AP2, which is the product that comes from the slat line. As you can see, we send this slat from Seville to our facilities in Almeria, also in Spain, and we do some screen in order to remove little bones and other solid, and then we formulate it with glycerol and some micro elements that are useful for our purpose. And also with AP3, we follow a similar scheme. In this case, what we do is, because of the size of the pool of the microalgae pool, what we do is to send glycerol to them. Glycerol is going to reduce the water activity, which is a way to reduce the possibility of contamination. And we send IBCs. This is an IBC, this kind of container, filled with 300 kilograms of glycerol, in order to be completely full completely filled with microalgae biomass. Then we send this IBC already full to our facilities, and over there in our facilities we screen it and pass all this biomass through a homogenizer in order to break down the cells and release the organic material that it inside these cells. Sorry, here you can see some tests we did at the very beginning. What we do was some kind of scouting. We give to very close farmers. We give 10, 20 liters in order to try it with different crops and in different situations. and with the idea to get feedback, because at the beginning we didn't know for what we can use it. Maybe for seed germination, for increasing the sugar in the melon, for example, or we didn't know what can we expect from this product. So we sent a lot of samples to many close friend farmers, and we get some feedback. Here you can see a test in which we try our, in this case is AP2, against some control, in this case agrobiotic, which is a product of our company, of Kimitec. And as you can see, the product, the commercial in the commercial unit figure, the product 2, the AP2 it has an biostimulant activity, but it's not as good as our product as agrobiotic. Here you can see another test, in this case with cucumber, and again AP2 performed good, better than the control, and also better than the positive control, which is Gulnova, which is a product from also a commercial product, but for not from us. Again, our product agrobiotic is performing better. That means that it is a biostimulant, but we already have better biostimulant of this kind, which is a kind of that contain microorganisms alive. And again, another test with tomato, more or less the same. Our product agrobiotic is better than AP2, but AP2 is performing reasonably good. So right now we are running a much bigger test with AP1, AP2, AP3 in 2 ways: fertilization and foliar application. At the very beginning, we started just doing a running test with AP2 because we thought that the commercial production of this pilot plant is going to be the volume of AP2 is going to be much higher than the volume of AP3, because AP3 is the production of microalgae biomass, and they taking into account the size of the pool, it shouldn't be so a huge production. But when we perform this scouting and we give some sample to these farmers, they give us a very good feedback. Overall, in flowering activity and also in fruit setting. So we started to run a specific tests with this application. And here you can see, in this case, we are mainly focusing in AP3 because of the good result we are obtaining with flowering and fruit setting. And you can see, for example, in this case, this is a test in Murcia with apricot. Murcia is in Spain with apricot. And what we are looking for is to get a better homogeneity in the flowering and the fruit setting of these apricot trees. Here you can see some tests also with those application. The positive control, which is Edgar from Balagro, another company. And as you can see here, for example, this is the activity of Edgar Balagro. You can see here there is no in this branch there is no the branch is not very homogeneous. You can see some flowering bud and also some flowers, and this is a problem because when the farmers want to pick up the fruit, if there is not homogeneity, they have to get into the field several times in order to pick manually this fruit. If you get a most homogeneous fruit setting and flowering, you will get a most homogeneous production, and then you have to get into the field just once with the manual picking. here you can see also several another test. And well, here is in this figure you can see how our product AP3 at 2 different concentration increase the flowering activity and the fruit setting from the control. I'm sorry if you are hearing a sound. It is raining a lot, and it was not planned to rain so much. Sorry. And you can see as our product AP3 is competitive with the chemical control. It's much better than the organic product from the competition, and it's competitive, even better than the chemical control. So that is.
Thank you very much, David, for your presentation. And we were able to hear you very clearly, despite the sound that you mentioned in the background. But yes, thank you. It's always good to see the scientific side of things and the actual results. Next presentation will be the environmental assessments. Ms. Gulgan from 2B will be presenting next. Welcome and good morning, and we look forward to your presentation.
Okay, thank you very much. Now I am going to share my screen. Okay, I hope you are seeing my presentation well, correct? Okay, is everything fine with my presentation?
Yes, your presentation looks clearly. It looks in presentation mode.
Okay, thank you very much for the feedback. Good morning, everyone. First of all, thank you for the opportunity to present our work today. My name is Gulgan Acar, and I am presenting 2B SRL today, which is the one of the consortium partner of Water2REturn project. We are a sustainability consultancy agency based in Monteleone, Veneto, which is a small and cute town very close to Venice in Italy. We help to do companies, universities, institutes, as well as European projects for sustainability assessments and environmental communication. And we mainly do these three methodologies: life cycle assessment to evaluate the environmental impacts, life cycle costing to evaluate the economic impacts, and social life cycle assessment to evaluate the social impacts of a product, system, or institute or an organization. These three aspects are very important for the sustainability, because sustainability lays on these three pillars, which are environment, economy, and society. And I would like to speak a bit about the life cycle assessment to understand the methodology before giving some results of the Water2REturn system. Also, life cycle assessment is the one of the oldest one among these three methodologies, and it is a study to evaluate the environmental impacts of a product, system, or organization from beginning till to end of the process, which means that it starts with extraction of the raw materials, a production stage, a transport stage, using and disposal of the waste. So you can consider as a cycle of life along of a product, service, or organization. So let's explain it with an example. The most common application of LCA for a product, and let's think about a bottle of milk, and we want to evaluate its LCA. And you can consider that, okay, we have a cow, we obtain milk from it, but in reality, it is a bit more deeper. And now we have seen a life cycle. And if you focus on the yellow one, it is the feed, animal feed. And honestly, it has to start with the feed. Feed, transportation of it, and feeding the animal at the animal farm, then obtaining the milk, treatment of milk at a different plant, bottling it and transporting to the supermarket and keeping in the refrigerator or keeping on the shelf in the supermarket. And customers go by their car, they bring and used at their home, and finally the bottle became disposed, became a waste. But still some points are missing here. So our studies are a bit more deeper than this. So for example, we must start with the animal feed, and also animal feed has its own life cycle before producing it, starting from the planting the plant. Also, we have to consider the animal itself, because a cow is not only for obtaining the milk, also meat can be used. And this point is important because in your process, you have multiple outputs. You have to consider also the impacts. You have to allocate the impacts for different outputs, not to make any mistake. So now we are interested in a bottle of milk, but we must consider even the feed processing, even if we are not interested. But this is the correct way to allocate the impacts and present a correct assessment. Not only this, we have to consider the treatment plant for the milk processing. We have to consider the production of milk starting from the glass. Okay, in the supermarket we have refrigerator. We must consider how to produce it. And even if we are going to supermarket by our car, we have to include also the production of car and all consumptions related with our car. And so these cycles are spreading a lot. As you can see, it is very deep and a complete study to understand the entire impacts of a product, service, or organization. So some more information about the methodology. When we are implementing life cycle assessment, we considered our product, service, or organization as a box. So we investigate what is input, what is output. Input might be materials, energy, water, consumptions, while output not only product as well as byproducts, waste, emissions. So, and also we have some opportunity to evaluate the environmental impact in different terms of impact categories. For example, the first one, climate change, is the most popular one today, and to understand carbon dioxide equivalent emission to the atmosphere. And but also we can implement different impact categories to understand the environmental impacts in different categories, such as water use, land use, and eutrophication, acidification. And in line with this, we can understand the potential damages on the human health, resource depletion, and the ecosystem quality. Okay, when we implement life cycle assessment, we can evaluate carbon and water footprint, ozone layer depletion, acidification, eutrophication. While if we implement life cycle costing, we can understand the cost. And this is important. If we combine LCA and LCC together, we can obtain the eco-efficiency study, which is important for the companies. While for the social LCA, we can evaluate the different stakeholders, such as workers, local community users, or small companies. Why do we use these methodologies? First of all, it is for improvement of our system or our production. As I said, if we combine LCA and LCC together, we can obtain the eco-design. And also with these results, we can set our priorities in terms of cost or time or other related. And mainly we use comparative assessment, so we can compare two different situations if we want to improve our product, or if you want to compare with baseline scenario, previous version and today's version. And also it is important for the communication for the companies. Additionally, they also help for the United Nations Sustainable Development Goals, as well as we can develop new strategies based on the results of sustainability assessments. Let's speak about the water-to-return system. And here on the left, we are seeing the baseline scenario, the previous version of before situation before the water-to-return plant. Okay, we are seeing Matadero del Sur. It is a slaughterhouse in Spain, and there are 3 ponds in the photo. They are very visible. And in the previous version, before implementation of the water-to-return system, there were 3 ponds used as a pre-treatment system, and which wasn't very sufficient. And water was, after this pre-treatment, water was transferred from ponds to the municipal wastewater treatment plant by trucks every single day. While on the right picture, we are seeing the water-to-return plant, and the wastewater directly from Matadero del Sur is treated here. Reclaimed water is obtained and discharged to the environment in line with the legal discharge requirement, of course. Then a nutrient is obtained, nutrient is recovered in terms of biostimulants. Now we are seeing an output of our model directly from the software. So this is the water-to-return plant is built in the software in our model for LCA in 4 lines, 4 treatment lines. And if you focus a little bit for the connections, you are seeing a thin or thick red lines. They are all representing the environmental impacts. And step by step, during these 4 treatment lines, all the environmental impacts are accumulated. And if you follow the thickest red line, all environmental impacts are accumulated from every single treatment line, and they are summed for the water-to-return system. So in this way, this is a smaller, shorter presentation, how we model it, how we calculate the environmental impacts. While for the social part, before social part, also for the LCA, we follow the same structure, and we add the cost both for primary data and the secondary data. For the social part, we investigate 3 stakeholder groups, which are workers, local community, and users. And for each stakeholder group, we have dedicated social topics to evaluate the social impacts. And if you see them, health and safety is must for each stakeholder groups, specifically for workers, remuneration, discrimination, freedom of association and collective bargaining, and work-life balance. While for the local communities, apart from health and safety, access to material and immaterial resources, community engagement, skill development, and contribution to economic development. While user, we consider only health and safety, social topic. For the social LCA, apart from the preliminary data that we obtain directly from the water-to-return plant and the consortium partners, we also use those secondary data from this database. This is a social hotspot database, and all social impacts are separated, distributed all along the world, and we can see in different colors where the social impacts high, low, or medium. So how we are going to read this map? If we see the darkest red, which means that the social impacts are very high in those countries, and while the green one represents the lowest social impacts, if it is yellow, it means that it is an acceptable risk, which is our target to reach the minimum. At least we are expecting to reach the yellow part. And if we see blue parts, there is no evidence of any social impacts, social risk, and gray small parts are no data. So in line with this, let's see our results. For LCA and LCC, we are following the same structure. We have two models, but it is built in the same structure. So I prefer to sum all in the same presentation. And for LCA and LCC, we implement a comparative assessment. We have water-to-return system with nutrient recovery. We obtain agronomic products, which are biostimulants. We compare this water-to-return system with a baseline scenario. For the baseline scenario, we choose a conventional wastewater treatment plant with anaerobic digestion unit, which means that we are recovering energy, but we don't recover nutrients. And also, we implement two different capacity scenarios here because it is a full-scale demonstrator, but it is built for 50 cubic meter per day wastewater. But also, statistically, we know that slaughterhouses have more wastewater generation every day. So also, we implement full capacity scenario, which is based on 150 cubic meter per day. But we have some adjustments here since the project had some adjustment last summer. So these numbers slightly a bit change. So 50 cubic meter per day treatment of wastewater became 54 cubic meter wastewater per day. While for the full capacity scenario, we simply multiply this amount of wastewater by 3. Another important thing to understand our results for LCA and LCC, we implement the avoided product. For the LCA and LCC, we considered that chemical fertilizers are avoided product if we produce biostimulants from water-to-return system. What does it mean? Because we know that these biostimulants cannot be replaced directly instead of chemical fertilizer. If a farmer going to use biostimulant, he or she must still use chemical fertilizer. The benefit coming through the biostimulant might be increasing the productivity of the product and or reduction of the consumption of chemical fertilizer. Since the first case is quite difficult to evaluate because it depends on the which kind of fruit or vegetables or grain are you producing, and they have very variable price in the market. So that's why we implemented the second idea to understand that how many percentage of chemical consumption would be decreased if we use biostimulant. For this scenario, we implemented different percentages. So for worst and best case, we choose 1% and 10%. Also, to understand the trend better, we implement a middle point, which is 5% reduction on the chemical fertilizer consumption. Also, apart from that, we investigated also breaking points to understand that in which point we have the same impact with baseline scenario. For LCA, for both capacity scenarios, we receive 0.8% reduction of chemical fertilizer, while for LCC, for two different capacity, we receive two different breaking points, which are also very close to each other. 2.5% for the 54 cubic meter per day capacity, and 2.1% reduction for full capacity scenario. In addition to these scenarios, only for LCC, we consider one more scenario. We implement biostimulants as avoided products because also in the market there are some other biostimulants, and they have a market price. So since we know the price, we know a potential price for these biostimulants, we implement it directly. We are avoiding to buy biostimulants directly from the market. So only for LCC part, we also investigated these results. Let's see some results. This page is dedicated for the LCA. And we use EF method, which is released by European Commission. And but we sum all environmental impacts in a single score. That's why you are seeing one number for each. On the left, we are seeing the 54 cubic meter capacity scenario, while on the right, it is representing a full capacity scenario. And if we focus on the left side, the first bar representing the total environmental impact of the baseline scenario. Second is it is breaking point, which is 0.8% reduction on the chemical fertilizer consumption. So we are seeing more or less they are catching each other. So if we implement 1%, we are already beneficial with respect to the baseline scenario. And if we even increase this amount, 2.3, 5, 10%, we are really beneficial in terms of environmental impacts. On the right side, when we implement the same reduction percentages on chemical fertilizer consumption, we are seeing the very similar trends. Okay, first one representing baseline, second is breaking point. We can think it is catching each other. 1% of reduction already beneficial, and more than 1%, it is extremely beneficial. Now we are seeing the same evaluation for LCC. In these graphs, the treatment cost in euro for 1 cubic meter slaughterhouse wastewater is represented. Again, the same mentality. On the left, a 54 cubic meter capacity scenario. On the left, full capacity scenario. First bar are representing the baseline, the cost of baseline for treatment of 1 cubic meter wastewater. Second bar is the breaking point for the LCA, but this breaking point, this reduction rate is not beneficial for LCC point of view. And also we are seeing the 1%, the third bar for each graph. Still, it is not beneficial. And on the left, 2.5, and on the right, 2.1% of reduction rates, we are catching the cost of the baseline scenario. After that point, if we increase it 5% or 10%, we are very beneficial. And there are 5th and 6th bars in each graph. And we have one more extra scenario in LCC. If we focus on the last bars in each graph, we are seeing the scenario when we implement the biostimulants directly as avoided products. So due to their high cost respect to the chemical fertilizer, we are seeing that we are very beneficial. Let's speak a bit for the social part. A social LCA is elaborated in two parts, both quantitatively and qualitatively. Quantitatively, following the same path like LCC, I think we saw enough numbers. I would like to speak something different here for the LCA, social LCA part. I would like to present the results for the qualitative part. Okay, this data is obtained both from the project partners and the secondary database, which I showed in the previous slides. So we are seeing here the plant construction. The water-to-return plant is built in 4 treatment lines, and we investigated a related partner for each treatment line for 2 stakeholder groups. On the left, the half, if we divide the screen to half, on the left, we are seeing the impacts on the stakeholder group worker, on the right, local communities. And as I described in the previous slides, and we have here different social impact categories, 5 for each. As we've seen how to read the hotspot analysis, if we have red, it is the worst case, worst social impact. If we have green, it is the best, the lowest social impact. If we have a yellow, it is not a very good but acceptable situation. So it is fine. And here, if I summarize, for the worker stakeholder group, we have the best results among each other. We have water line and the sludge line, while for the local communities, we have the best from sludge line and the second from water line. And the second part of the social LCA, we also investigated the plant operations. In here, we have a comparative assessment. We compare water-to-return system with the baseline scenario. But in here, we took to real situation before implementation of the water-to-return system as the baseline scenario, because there are really visible social impacts with applying the water-to-return system. So, in short, baseline scenario had a pre-treatment in 3 ponds, then transport of these wastewater to the municipal wastewater treatment plant, and the grease, fat material which is accumulated in these 3 ponds also used as animal feed, which means that there is an avoided animal feed purchase. While in the water-to-return system, we have wastewater treatment, we have biostimulant production, and we are avoiding to use chemical fertilizer in some percentages. So let's see what was the worst in the baseline scenario. If we we investigated for each step of the operation, again into stakeholder groups, you can see worker and the local communities. And if I go back to the worst case, we have here in the baseline, community engagement is red, because this pre-treatment and the grease and fat was, because of this, the company was receiving some complaints. And if we look at the water-to-return plant, now we don't have any green or orange. We have at least the acceptable condition and even more better condition. And I would like to focus on the avoided use of fertilizer. We are seeing blue boxes, which means that there is no impact. And the boxes white with frame with different color represented the avoided impact. For example, we are seeing 3 red with a white box, which means that these 3 unacceptable impact is avoided. So it means something good. Also for these 2 orange. So if I need to summarize all, what has been changed with implementation of Water2REturn plant for LCC, LCA, LCC, and social LCA. In LCA, before we had adverse effects of nutrient emissions on the environment. Now we are treating this water with recovering the nutrients, and in this way also we are meeting the requirements of the environmental regulations. For LCC, and we had wastewater and respectively sludge waste management cost. Now we don't have this cost. We are not sending the water to the municipal water treatment plant. Apart from this, we have revenues from the agronomic products, which are the biostimulants. For the social point, there was a transportation and some complaints about the wastewater. Now we avoid some negative effects of using a chemical fertilizer, both for environment and the human health. Before finalizing, I would like to speak about the layman's report. This is one of our responsibility to prepare layman's report, a standard document of European projects. Simply, it is a non-scientific explanation of the project. And in this document, we explain what is Water2REturn system, what are our objectives, what are our treatment lines, as well as our results, which is very important. And at the end of the project, you can download this document from our webpage, project webpage, as well as social media channels. So thank you very much for your attention.
Thank you very much, Gulgan. It was an excellent presentation. And yes, she did mention the website, water2return.eu. We'll put that in the chat in a minute. Also, don't forget, one moment. Gulgan, if you could remove the speaker, sorry, the video. And stop sharing. There we go. Thank you. Yes, we'll be sharing the website, water2return.eu. We will also give you the results of the poll, which is that the most popular language is Spanish for our attendees. So one of our videos will also be both in English for everyone here, as well as Spanish subtitles. Though an interesting thing from that survey, we had nearly everyone here speaks at least 2 additional languages, in addition to presumably English, as you're listening to my presentation in English, and hopefully everyone understands. Other than that, be sure to put your questions into the question and answer box. We have a few questions already, but yeah, be sure to ask us questions because we love talking about this project. We've been working on it. All of the partners here and the presenters have been on this project for almost 5 years now. So be sure to ask us questions. Finally, now introducing Marco de la Feld. I will be presenting on behalf of UECBV, and he'll be presenting for the industrial sector. So Marco, good morning.
Yes, Hey, Daniel, thanks a lot and welcome to all of you, and thanks for your time to these final events after a long time to develop this project. I'm here today to present the main results, in particular related with the meat industry, because like you have understand, the demo site has been done in Matadero del Sur, slaughterhouses in Spain, and the technologies that we have developed is mainly focused on the meat industry and for the meat industry. This is the reason why UECBV are playing an important role in this project. First of all, to understand the specific needs of the meat industries from one side, and from the other side, to make a strong stakeholder engagement to understand the specific needs and how our solution can support the concrete problem of the meat industry. Let's give a meat market overview at global and European level. The slaughterhouse legislative framework focus on the Matadero del Sur demo site, and at the end, the environmental and economic benefit of using Water2REturn solution. So, in general, the meat industry value at worldwide level in 2021, in 2020, have a value of $800 billion US, and the increase up to $1.157 billion. So it's an important market. The most promising meat market are the Asia Pacific with 49%, the North America the 20%, and the rest of the world represent the 31%. If we speak in terms of revenue of meat products and sausage market, the first country is the United States, followed by Germany, and the third country is Russia and France. So you can understand that France and Germany play an important role, and European is an important country in general for the meat industry. If we focus in the production of meat worldwide from 2006 to 2020, you can see that is growing from 300 million metric tons up to 328 million metric tons. So it's a growing market. And this is the reason why we need to be very carefully to the specific market needs of this market. In particular, you can see that pork play an important role in this industry in terms of production of meat at worldwide level. And the second product is the poultry, followed by beef and veal. If we speak about the consumption at pro capita of meat worldwide from 2018 to 2020, we can see that also in this case, North America is the first countries, Oceania is the second countries, and the third is Europe. The projection for 2030, we can see that there is an important increasement starting from 2021. Only a small reducing starting from 2006 up to 2031 is in Europe in terms of annual consumption. But this is a graph, but if we see the absolutely value, we see that we decrease from 38,000 tons up to 37,200,000 tons. So the decrease is very small. If we focus on the specific European countries, we can see that the most interesting in terms of consumption is Germany, followed by Italy and Poland and France. The Spain is the fourth country in terms of consumption. So you can see that meat represents an important industry at European level. So why we have focused our attention on this water-to-return solution is due to the fact that in peak production, the 62% of material is edible meat against the 38% of inedible meat. So it's mean that we have a lot of waste. So even if we are focusing on wastewater treatment, have the 38 of inedible meat, make this water extremely rich of nutrients and other secondary raw material. So breeding livestock transfers into generation of waste. However, it's during the slaughterhousing process that most organic solid waste is produced. The amount of solid animal waste will change according to the type of animal slaughterhouse. Furthermore, inspired of the actual filtration system in place, solid wastewater still contain a very high amount of organic and inorganic suspended solid and soluble particles, very high concentration of fat and nutrients. If we focus our attention on the regulatory aspect list, with UECBV, where we have focused our attention on water framework directive, the sludge directive, and the EU biodiversity for 2030 directive, in order to develop a solution that in any case is aligned with the actual and in the future legislative framework defined by the European Commission. About the first one, the Water Framework Directive is an European directive which consists European Union member states to achieve good quality and quantitative status of all water bodies. The Water Framework Directive stipulates that groundwater must achieve good qualitative status and good chemical status. As this document was written 20 years ago, Water2REturn far exceeds the requirements of this directive. If we focus on the sludge directive, it has adopted 30 years ago, and the new directive is being written with both the needs of the environmental as well the needs of farmer in mind. And over 65 organizations, including Copacogega and Fertilizer Europe, have given feedback. Water2REturn system fulfill the requirement of the previous sludge directive and should fulfill the upcoming directive. So we are trying to work in a solution that is actual today, but also in the future. Regarding the EU biodiversity strategy for 2030 is a comprehensive ambition and long-term plan to protect nature and reserve the degradation of ecosystem. Connected with the Green Deal Farm to Fork, is not linked with the Water2REturn project, and it shares many of its core goals, like reducing the use and risk of pesticide by at least 50%, increasing the use of organic fertilizer, and restoring degraded ecosystem. Will mostly have a positive effect on the project, and it will increase the use for organic fertilizer and the desire of circular economy approach. Because we never forget that the approach used by our project is a circular economy approach, so transform the wastewater coming from the slaughterhouses in secondary new raw material. And here you can have an overview about how the Water2REturn solution is in line with the different legislative approaches that the European Commission are following. So how is the actual situation? Current approach for treating slaughterhouse wastewater, in spite of all recognized benefit of adopting a circular economy approach, current practice tend to nutrients removal instead of recovery and recycling. With our project, and so with Water2REturn can be an alternative and more sustainable approach. In fact, it faced the environmental and economic constraints of the slaughterhousing industry as a market opportunity. At times to adopt a circular economy approach to extract the maximum value from slaughterhouses' effluents, and it makes possible to recover nutrients for slaughterhousing to wastewater and turn them into product with a value for the agricultural sector. Again, here we are trying to summarize the approach that we have followed. Starting from waste, in this case, wastewater, we are trying to have a secondary raw material with an added value. What about the demo sites in Matadero del Sur? Is a slaughterhouse in Salteras in Andalusia. This region we will know for the challenge it faces in terms of water scarcity, what makes Matadero del Sur a good place to test our solution. With an area of 80,000 square meters, we have 3 slaughterhouse lines, cattle, pigs, and sheep goats. And we have cutting and packaging room, and also a sausage factory and a slicing plant. So in this place, we are able to cover the entire production lines, and it was the best place where to test. Here you can see more in details the great work that has been done in order to build the different elements of our solution, because like my colleague had said before, this is a modular solution with a treatment capacity of 50 cubic meters per day. Of course, this is a demo site, but we can increase the capacity of this plant following the specific needs and to make this solution more convenient also from the economic point of view. The benefits are mainly focused on wastewater treatment. In fact, we have an integrated system to treat wastewater while recovering nutrients. And so we have a new combination of technology and process to maximize the extraction of valuable products. We have raw material extracted from slaughterhouses. We have 3 different raw materials will be the basis of future agronomic products. And we have 2 agronomic products, and in particular, 2 biostimulants that are free of pathogen and pollutants. In order to have a better quality of the best quality of the final product. In the same time, we have benefit in terms of inexpensive, because the price is reasonable. It could be makes other fertilizer cheaper. In fact, we add more fertilizer and bioproducts to the market, and it's in line with all the existing legislation, like we have discussed before, and our solution fulfills the legislation on the agronomic product and on manufacturing and use. So we can say that is a project that sees the future. In terms of the environmental benefit, and in the next 2 weeks, we are going to confirm this value. We have a wastewater discharge reduction of 90%. We have a reduction in waste delivered to landfill of around 80%. If we speak in terms of recovery rates, we have freshwater saving that is between 20 and 40% in the meat industry, and this is an important result that we have achieved, and we have nutrients recovery between the 90 and the 95%. Just to give you an idea about the treatment cost with the conventional solution, actually the cost is of 2.63 euro per cubic meter of water. With our system, we are able to decrease this cost up to 1.85 euro per cubic meter, with a cost saving of around 30%. Of course, this is an average value and depends from the different condition of the slaughterhouse. In terms of business opportunity for the involved sector, new opportunity for wastewater treatment, energy engineer, and consultant companies. We have new products for the manufacturer of biostimulants, and for sure we have new opportunity for the slaughterhouses and in general for the meat industry. Who are our potential clients? Slaughterhouse industry are the early adopter, and in particular the meat processing industry. From the other side, we have bio-agronomic product distributors, and for the agriculture sector, we have the conventional and the organic farm. Other added value of our solution for this specific sector is that is a modular system to be tailored for future clients according to their needs and expectation, and is a high replicability. So it's flexible system to be adopted to other food industry. Work done to UECBV during the project development has been done in particular to understand the specific needs of the meat industry, to understand how to change a little bit the proposed solution to solve the specific problem. This work has been done with the online survey, where we have invited all our members to fill this survey to better understand their actual solution in terms of waste of water, and to understand if the system that has been developed was in line with their needs. So we can see that at the end, the cooperation with all the other technical and non-technical partners, and in particular with ILO, was fundamental in order to develop a circular economy approach for the meat industry and for the fertilizer industry in general. I'm quite happy because most of the results has been succeed, and we have reached what was in our mind. So that's it from my side. Thanks a lot for your attention, and I remain at your disposal for any kind of specific question.
Thank you, Marco. We look forward to discussing with you during the question and answer, especially with your expertise in the industrial sector. You can hopefully answer a lot of those questions, as we have many people from here, from that sector. Also, more updates. We do have on Twitter, there's been a hashtag, so I'll be sharing that with you right there in the chat. You can share the event. A couple of people have already been sharing it, but we welcome more tweets and let people know about this great event going on. As well, the email address, the website for the project, water2return.eu. You should be able to, when you have a chance after this conference, check out all the various outcomes, news and events, including this one, and we have a few upcoming events. Resources, all the different outputs that we've had from the last 5 years. So, yeah, we look forward to it.
Yes, Daniel, I would like also to say that on our website, it will be possible to download all the report, and in particular, the detailed business plan, or in any case, the public information to have all the information also on the cost of our system. And so please follow us on our social media, on our website, so you can receive the latest news about our technologies.
Thank you, Marco. Yeah, that's probably going to be one of the most important questions, is the cost of the system and how it works for the various, both people from the industrial sector as well as people from the farming agricultural sector. Now we will be introducing our guest from another project, Laia Llenas Argelaguet, Deputy Director from Beta Technological Center, and she'll be presenting on behalf of the FERTIMANURE project. Thank you for joining us and introducing your project, and we look forward. We, of course, here at ELO know a lot about it, but we're excited for you to share it with the rest of the audience. Thank you.
Okay, can you see my presentation?
I can see it, and I now see it in presenter mode. So yes, it looks
great.
Good,
okay, so thank you very much, Daniel, for your introduction, and also thank you very much to Water2REturn project to invite me to this final conference to present you briefly about the FERTIMANURE project. I have mainly focused my presentation in the part of nutrient recovery because that was the main topic of this final conference. So just briefly about FERTIMANURE. So FERTIMANURE is a 4-year project started in January 2020. So now we are more or less in the middle of our project. We are a total of 20 partners from different EU countries, but also from the CELAC region. So we have Argentina and Chile as part of our consortium because our project is also willing to have some impact in the CELAC countries. And here you can see the consortium, which was built following a multi-actor approach. So we have research centers and universities, but we also have farmers, policymakers, technology providers, the fertilizer industry, also multipliers that allows us to reach more stakeholders during the project execution, and partners expert in the business development part. So FERTIMANURE project was built to give an answer, to provide an answer to those challenges related to manure management. So these challenges are mainly the increasing global demand for mineral fertilizers and also a resource depletion for obtaining these nutrients. We also have a challenge regarding the regional nutrient imbalances. So there are European regions with a high amount of nutrients, with an excess of nutrients that cannot be used, and regions which have a deficit of nutrients. So it's nice to consider these imbalances to properly manage nutrients at EU level. And also there's a challenge related to lack of mature technologies for nutrient recovery, considering also the costs of these technologies. More focusing on manure. So manure is one of the sources with a higher amount of nutrients, and we are producing lots of manure in Europe. So more than 1,400 million of tons per year are produced, which contain a high amount of nitrogen and phosphorus. And nowadays, more than the 90% of this manure is currently returned to agricultural fields directly with no specific manure management strategy. And we also have challenges related to regulation and social acceptance of bio-based fertilizing products. So with FERTIMANURE, what we want is to provide real benefits and solutions to all those stakeholders that are facing these challenges related to an inefficient use and management of manure. So we want to provide benefits, for example, to the livestock sector, by providing them new business opportunities in the fertilizers market with the nutrients that the manure are containing. Also for the agricultural sector, we want to provide them new fertilizing products that can be of the same quality or even better than the current mineral fertilizers that they are using. Also for the chemical industry, the fertilizing industry, we want to provide them with new nutrient sources to produce their fertilizing products. The technology providers will also have new market opportunities for all these technologies related to nutrient recovery. And also for the society, we want to provide with alternative nutrient sources that in the long term has to ensure food security and sustainable agriculture. So the main objective of our project is to develop, integrate, test and validate innovative nutrient management strategies to efficiently recover mineral nutrients and other relevant products with agronomic value. And this includes organic amendments and biostimulants apart from the mineral fertilizers. And these products are obtained from animal manure. And the idea is that we can obtain products that can compete in the European fertilizers market. So here I'm showing the circular economy strategy of the FERTIMANURE project for a more sustainable manure management. The first step in this approach would be to implement nutrient recovery technologies to obtain bio-based fertilizers from animal manure. Once the nutrients have been recovered, we are considering three possible strategies to be followed. These are the three ones that I'm showing in this figure. This first step is that the bio-based fertilizers that will be recovered on farm with the technologies can be directly used in the same farm or in the surrounding areas. Second strategy will be to use these bio-based fertilizers to be sold to the chemical industry and to produce what we call tailor-made fertilizers, that I will more specify later what exactly do we mean with tailor-made fertilizer. And the final strategy is to produce directly tailor-made fertilizers by mixing animal manure with different supplements or additives. This third strategy is based on a patent that FERTINAGRO, which is a partner in our project, has. So at the end, we are considering different strategies targeting different farming systems. So first approach, it's targeting mainly mixed farming systems where the nutrients that we are recovering can be directly used, whereas the second and the third one can be used in those cases where they have an excess of nutrients, so should be exported from the region, so should be used to produce more attractive products that can be sold in the market. So here I'm showing what do exactly mean with the bio-based fertilizer and also by tailor-made fertilizer. So a bio-based fertilizer from FERTIMANURE is that we are considering them as fertilizing products or a component to be used for producing tailor-made fertilizers, and that are directly obtained from biomass-related resources. So in our case, the bio-based fertilizers are obtained through a physical, thermal, thermochemical, chemical, and/or biological process from the treatment of manure or digestate that results into a change in composition due to a change in concentration of nutrients and their ratios compared to the input materials. So at the end, we are not considering a bio-based fertilizer directly, for example, the liquid fraction or the solid fraction of manure. So the manure has to follow different treatment steps to specifically recover the nutrients that this waste is containing. And a tailor-made fertilizer is a customized fertilizer that meets with nutrient requirements of a specific crop, but by taking into account the soil type, the soil fertility status, and growing conditions and fertilization practice in the area where it will be applied. How we are obtaining the tailor-made fertilizer? So we are obtaining a TMF by mixing different of the bio-based fertilizers recovered, and also, if needed, with other additives or mineral products to finally obtain the nutrient composition that the crop would need. So in the project, we are producing these two types of products, bio-based fertilizers and tailor-made fertilizers. How we are obtaining that? So we are obtaining that through our pilots. So in the project, we have 5 on-farm pilots. So the pilots that we have in FERTIMANURE are directly located in different farms in Europe. And the pilots are treating different types of animal manure. So we are considering pig slurry, cattle manure, and also poultry manure. And our pilots are located in Spain, France, Belgium, the Netherlands, and Germany, which are regions with a high livestock production. So they are generating lots of animal manure, and they have to find alternatives to properly manage this type of waste. So now in the presentation, so I will go very briefly to show you the 5 pilots that we have in the project. Then if you have more questions about some of the pilots, I can try to answer some of them. I know well the Spanish pilot because it's the one in my research center is working, but also for the other pilots, I can also provide contact of the project partners if you have interest for some of them. So I will go briefly to the 5 of them in order that you can see what are we treating in each one and which are the products that we are producing. All the pilots are now operative, so we are already working in all of them. We are obtaining products, and we have also started the agronomic assessment of these products. And we are now also in the part of optimization and getting all the data that we have that we will need to do a proper evaluation of all the process. So starting for the Spanish on-farm pilot, the pilot plan in this case is installed in a farm called Calros. It's a pig farm located in a municipality of the central Catalonia. And this farm is managed by one of our partners, which is Cooperativa Plana de Vic. So apart from Cooperativa Plana de Vic, in the Spanish pilot, we have involved 3 other partners. It's Beta Technological Center, Leitat Technological Center, and also the company Alga Energy. So in this case, this pilot has a treatment capacity of 3 cubic meters per day. And main innovations in these pilots are the implementation of membrane contactors for nitrogen recovery, the implementation of freeze concentration, the production of biostimulants using microalgae, and also the valorization of the solid fraction of manures, recovering phosphorus in a phosphoric acid form. So here in the right part of my slide, you can see the infographic of this pilot. In blue, you have all the technologies that we have installed in this pilot. And in green, you have the 5 products that we are obtaining in the Spanish on-farm pilot. So we are recovering phosphoric acid and a pH-rich organic amendment from the solid fraction, and ammonium sulfate and natrium-rich concentrate and biostimulants from the liquid fraction. So here you have a picture of the location of this pilot and also some pictures of the pilot itself, which as I said, it's fully operative, treating the pig slurry generated in this farm in Catalonia. But also apart from pig slurry, here in this pilot, we will also treat poultry manure. So although the main feedstock is pig slurry, we will also be testing poultry manure. So the second pilot, it's located in the Netherlands. It's specifically in the Argent Prinsen farm in the Asch-Terhoek region in the Netherlands. Argent Prinsen is also a partner in our project, and in this pilot we have also involved Wageningen University and Research and Dorset Green Machineries. This pilot is focused on the treatment of cattle manure. And the main innovations, it has a treatment capacity of 8 cubic meters per day. And the main innovations are that it is combining biological acidification and phosphorus recovery system and the nitrogen recovery from the acidified liquid fraction. This pilot, differently from the one in Spain, includes also anaerobic digestion. So we are in this case directly taking the cattle manure to an anaerobic digester where it is mixed with other co-substrates like beet tips, feed residues, or grass. So, and then we are valorizing the digester. Here you have the location of the Dutch pilot and also a picture of this pilot, which is also fully operative. Then we have the German on-farm pilot. In this case, it is located in the Fraunhofer facilities. And Fraunhofer is the only partner involved in this pilot, which is willing to valorize cattle manure. The main innovations of the German pilot is the catalytic reforming of the manure with zeolite, a selective ammonium recovery directly from a thermocatalytic reforming gas stream, and the phosphoric acid leaching of the thermocatalytic reforming biochar, and the change reaction to produce solid ammonium phosphate. So in this pilot, we are obtaining 3 different products. So a solution of ammonium sulfate, the biochar, and the monoammonium phosphate, which is a solid product. Here is the location of the German pilot, and also some pictures of this pilot plant, which has a treatment capacity of around 3 cubic meters per day. So here is the case of Belgian on-farm pilot. The main partner involved in this on-farm pilot is Ghent University. And Ghent University is doing the follow-up of the products obtained in different already existing plants in Belgium, although they are doing a more detailed analysis and balance of a pilot located in Detricon, which is located in a farm that has 11,000 pigs. So in this case, the main innovations of the Belgian pilot are the secondary ammonium sources obtained from stripping and scrubbing technologies. So main technologies of the Belgian pilot are the stripping and scrubbing to recover ammonium products, ammonium fertilizers. And as I said, this pilot is operational, but also from our Belgian partners, they will be analyzing bio-based fertilizers obtained in other pilots already existing in different farms to follow up the product quality and to test these bio-based fertilizers obtained in this case from pig slurry. Here is the location of this Detricon plant that will be followed in more detail, and also some pictures of this Belgian pilot. And the last one, the fifth pilot, is the one in France. And this case, the French pilot will run using on-farm mobile units. So in this case, we have a mobile pilots that has been built in trucks, and in this way we will be able to use them in different farms. So we'll be used in different farms that are located in the Grand East and Brittany French regions. So in this case, the mobile pilots are focused on stripping and pyrolysis. So the pyrolysis unit, the mobile pyrolyzer is obtaining biochar, and the mobile stripper is obtaining ammonium sulfate and a liquid potassium-rich product. So in this case, we are aiming to test these mobile units in different farms of these two regions that you can see in this map. So in the Grand East and the Brittany regions. And here you can see some pictures of these two mobile pilots. So as you can see, these are different approaches. So we have 5 different pilots using completely different technologies with different approaches, treating different types of livestock waste. And at the end, if we put together all the work done in the different on-farm pilots of the FERTIMANURE project, we are obtaining a total of 19 bio-based fertilizers. So as I said, the bio-based fertilizer are the products, the nutrients directly recovered from the pilots in the farms. And here you have the list of products that we are obtaining, and also some pictures of these products. And what we are doing with these products is to directly test them, but also we are using these products to formulate tailor-made fertilizers. So how are we working to obtain these tailor-made fertilizers? So what we have done is to create the TMF nutrition tool. So the TMF nutrition tool is an Excel tool that is aiming to be easily used for all the farmers and stakeholders that can be interested in formulating tailor-made fertilizers. And this tool is considering the sources that we are using to obtain the nutrients. So the manure fractions, also the nutrients that has been recovered from the different pilots, and other additives to formulate and to have the desired nutrient content. We are also considering the soil crop requirements. So which crop are we willing to use these fertilizers? Which soil in which soil do we have these crops? And also possible legal restrictions of the region where this TMF will be applied, in order to have clear which are the limit nutrient content of these products. And considering this, we are putting all this information in the tool, and the tool is providing you how do you have to mix the bio-based fertilizers obtained in FERTIMANURE, which are the required external outputs, and then the final product that you have, the content of potassium, phosphorus, nitrogen, and other nutrients to be directly used to fertilize your crop, to have your fertilizing plant. Also, once we have the BBFs and the TMFs, what we are doing in the project is to test their agronomic performance and to see, to compare them with current mineral fertilizers that are currently used. So we are doing tests in control conditions, so at lab scale, where we are assessing nitrogen, phosphorus, and carbon dynamics of our products compared with the mineral fertilizers in control conditions. Then we are also doing field trials. So we are doing field trials to evaluate in a real scenario the performance of our products, and we will be also doing demonstration, field size, and interactive events to show the stakeholders how our products. From the moment, so we are now doing the field trials and the pod test and incubation test, and for the moment, what we are seeing is that our products have the same quality, so no major differences are seen between using our products with the commercial ones. So in terms of agronomic performance, for the moment, the results are good, and we are obtaining no difference are seen between our products and the commercial ones. And the other important thing will be to evaluate the sustainability of what we are doing, the sustainability of obtaining these products, of implementing these technologies, of applying our products in the field. So we are doing a complete environmental, sustainability assessment, considering the environmental part, the economic part, and the social part, following a cradle-to-gate approach. So considering all what is done in the farm, all what is done in the production of tailor-made fertilizers, and also considering the application of these products. So thanks to this assessment, we will be able to tell the benefits of our process in terms of environmental, economic, and social point of view. And to finish, so another important part of our project will be all this related to exploitation. So we want to demonstrate how our process, how our technologies and our products can really be new business opportunity for farmers and for the fertilizing industry. So we will be developing a specific business models for farmers and for fertilizing industry, and business plans for the three types of end products that we are obtaining. And we are doing that with a constant contact with the relevant stakeholders. So we are doing brainstorm sessions. We are sending questionnaires to the stakeholders. We are also working in the performance of a market analysis in order to receive this feedback from stakeholders to produce these business plans and business models, and to do a good exploitation of our results. And as I was saying in the beginning, we are doing it at European level, but also we will be focusing on how our project can be exploited and can have an impact in the CELAC region, and more specifically in Argentina and Chile, where we have our partners. And that's all from my side. Thank you very much, and I will be happy to answer any questions that you may have.
Thank you very much, Laia. As she said, be sure to include questions. We will have a question and answer session after my presentation. Yeah, excellent presentation. And if you can stop sharing screen, I'll be
I stopped
sharing
already.
mine in a minute.
I stopped, yeah.
I also want to say it's great, the synergy of these two projects. We have the slaughterhouse waste and the manure, both of which are not some of the most pleasant results of the farm, or taking these products and turning them into advantageous things, fertilizers, nutrients. That's part of what that's a large part of the circular economy. So it's great hearing from your project and wonderful. And now I will share my screen. Good afternoon. My name is, mentioned earlier, Daniel Monteleone. I'm from the European Landowners Organization, where I'm project officer. I'll be sharing the perspectives for the farmers and the others in the agricultural sector. So first introduction, we're going to talk about the regulatory aspects of biofertilizers, the importance of organic fertilizer, the environmental benefits of the water-to-return products, and economic security. Regulatory aspects, we're going to discuss INMAP, national policies, EU fertilizer regulation, the farm-to-fork strategy, and then these last three, sewage sludge directive, water framework directive, and EU biodiversity strategy for 2030 will not be discussed because, of course, as you were hearing earlier in this presentation, they were discussed by Mark. So what is INMAP? INMAP stands for the Integrated Nutrient Management Action Plan. So what the Commission, the European Commission, will develop an integrated nutrient management plan with a view to ensure more sustainable application of nutrients and stimulating the markets for recovered nutrients. The Commission will also consider reviewing directives on wastewater treatment and sewer sludge, and will assess natural means of nutrient removal, such as algae. If you see the words I highlighted, wastewater treatment, sludge, natural means of nutrient removal, these are key parts of our project. Water2REturn is a project that deals with wastewater treatment and sludge and assesses means of nutrient removal, including algae. INMAP, we also presented this project to the European Commission last March. This is what we advocated for. Standardization of regulations across the EU instead of 27 different regulations. I'm sure you recognize that from different countries in the EU, there's often different rules, so it'd be great to have one set of rules across the whole board. We advocated giving incentives to farmers for using biofertilizers, what we'd call the carrot, rather than punishing them for not using them, or the stick. Let's talk about the EU fertilizer regulation, 2018-19. Goes into effect July 16th, 2022. These are some of the changes from 2003. It's opening the single market for bio-based fertilizers, which is important because that's what these fertilizers that are being developed are. The agreement on the fertilizing products regulation will open the market for new and innovative organic fertilizers by defining the conditions under which they can access the EU single market, as well as rules on safety and quality. The new regulation will provide strict rules on safety, quality, and labeling requirements for all fertilizers to be traded freely across the EU. Producers will need to demonstrate that their products meet these requirements before affixing the CE mark. Other changes, EU fertilizing products divided into different product function categories, which should each be subject to specific safety and quality requirements adapted to their different intended uses. Introducing new limit values for contaminants in fertilizers, as well as component materials for EU fertilizing products divided into different categories, which should each be subject to specific process requirements and control mechanisms. It should be possible to make available on the market an EU fertilizing product composed of several component materials from various component material, where each material complies with the requirements of the category to which it belongs. Basically saying that if there's different fertilizers, different bionutrients, you can combine them into one, As long as each of its individual parts are safe, then all the combined fertilizer will be safe. Farm to fork strategy, of course, many in the audience are familiar with it. One of its key things is a reduction of nutrient loss by at least 50% while ensuring there is no deterioration in soil fertility. Will reduce the use of fertilizers by at least 20% by 2030. This is where the INMAP was also proposed. National policies, of course, as you heard earlier, nearly every member state has their own rules and restrictions on biofertilizers. When the original legislations were written around the year 2000 for the EU, they were pretty innovative, but now most member states surpassed the existing EU policy. However, with 27 different countries, it becomes difficult to determine what sorts of biofertilizers to invest in when the national laws can change at any time. Organic fertilizers, what are these? They're substances that are derived from the remains or byproducts of organisms. They're rich in phosphorus, nitrogen, and potassium, but in unequal amounts. Two types of organic fertilizers, synthetic, which are organic compounds produced artificially, such as urea. There's also natural ones, which are 100% of the ingredients come from nature. For example, manure, compost materials. Examples of organic fertilizers, cottonseed meal, blood meal, fish emulsion, and manure and sewage sludge. What's an inorganic fertilizer in comparison? Any inorganic material of wholly or partially synthetic origin that is added to the soil to sustain plant growth. Chemical fertilizers are produced synthetically from inorganic materials. Some examples of these: ammonium sulfate, ammonium phosphate, ammonium nitrate, and ammonium chloride. So many ammonium-based products. But of course, you're asking yourself, why are organic fertilizers so important? They improve soil quality. Due to the organic material of the fertilizer, soil improves its ability to hold onto water and nutrient increase. Microbes thrive. The organic fertilizer is rich in organic matter, naturally helping microbes thrive. Synthetic fertilizer consists of chemical molecules without carbon, which can be disruptive. It avoids plant damage. Sometimes synthetic fertilizers can cause plant damage to both leaves and roots. This is much less likely with organic fertilizers. And finally, sustainable and environmentally friendly. Organic fertilizers also increase species biodiversity by 30% compared with synthetic fertilizer. And lastly, reducing fertilizer and pesticides can be cost neutral and sometimes even cost savings, as it can reduce the need for pesticides and the overall nitrogen, phosphorus, and potassium requirements, even though it can sometimes be more costly at first. Of course, we do address the negatives of organic fertilizer. Not all products are created equal. Sometimes organic products produce inconsistent results because they come from life, and life is complicated, as opposed to chemicals, which are straightforward. So make sure you're selecting a product that is industry vetted by reviewing any university studies and or case studies, which for the Water2REturn project are available on the website, and we'll have more in the next couple of weeks. Nutrient levels can be below the level of nutrients present in an organic fertilizer is often low. Environmental benefits, wastewater treatment, integrated system to treat wastewater while recovering nutrients. It's a novel combination of technologies and processes that maximize the extraction of valuable products. It can be customized to the needs of the end users. Raw materials extracted from the slaughterhouse. There's 3 different raw materials will be the basis of future agronomic products. Nitrate, phosphate concentrate, hydrodized sludge, and biomass, as well as 3 produced agronomic products, 1 organic fertilizer, 2 biostimulants. I know these were mentioned at the beginning of the conference, but they'll be free of pathogens and pollutants, and they will enhance nutrient efficiency, abiotic stress tolerance, and or crop quality traits. These 3 agronomic products, the 1 fertilizer and 2 biostimulants. The fertilizer is a soluble nitrogen and phosphorus. We call it SRM1. And the biostimulants are the hybridized sludge, enhancing nutrient efficiency, abiotic stress tolerance, and crop quality traits, as well as algal biomass, SRM3, which is an algal-based biostimulant. But most important, the environmental benefits of Water2Return. These products are free of pathogens, heavy metals, and emerging pollutants. So it gives safe reuse of slaughterhouse wastewater in the EU as well as abroad if the product fertilizers are exported. Also, as mentioned during the previous presentation by Marco, it's still inexpensive, still makes other fertilizers cheaper, and it's still in line with all existing legislation. And the final part of the presentation is the economic security. As you've been seeing, the situation in Russia has jolted the fertilizer market. Russian-Ukraine crisis ignites fertilizer prices at a critical time for world crops. CF Industries boosts US fertilizer shipments as war cuts Russian exports. And of course, the Russian invasion of the country, known as the breadbasket of Europe, has exposed just how much the EU relies on Russian fertilizer and Ukrainian corn to feed its animals. Economic security, I'm sure for the farmers here, you recognize the costs of fertilizers have gone up by 253%. As well, Russia is responsible for 14% of global urea exports and 14% of global monoammonium phosphate exports. And hopefully you can see my mouse on the screen. This is a presentation or a chart from Fertilizer Europe. This is the exports of Russia for fertilizers into Europe. This is Belarus. As we know from the situations that have been going on recently, it's important to be able to recognize that there might not be stability in the market. So it's best to get a product that's coming from the EU itself rather than external countries. So in conclusion, using a EU-based fertilizer would make you less reliant on fertilizers from belligerent countries. And as an added benefit, if it's made in the EU, you know where the materials are coming from. And of course, now, the exciting part, we have a video. The Water2Return has commissioned videos to explain the process. Although you've now heard about the process from other speakers, we're excited to show you the video for those of you that are visual learners. Martin, would you be so kind as to share the videos? Our first one is a live action video. And yeah, here we go.
The purpose of the Water2Return project is the recovery and recycling of nutrients within the framework of circular economy, embodied in the implementation of an integrated solution for the treatment of wastewater from slaughterhouses, as well as the recovery of nutrients with a high market value in the agricultural sector. Industrial slaughterhouses are noted for a high consumption of water and energy, as well as for generating vast amounts of wastewater. These wastewaters contain a huge amount of nutrients, and the tendency is to treat them and dispose of them, instead of using methods for their recovery. On the other hand, the use of chemical fertilizers is ever increasing due to the need to feed a growing global population under limited availability of farming land, with all the ensuing environmental implications like hypertrophication of masses of water. Water2Return proposes an alternative, sustainable approach, a real technological breakthrough developed within the framework of a circular economy. Water2Return is a system that allows wastewater from slaughterhouses to be treated whilst also recovering the nutrients, thus becoming secondary raw materials used to manufacture agronomic products, specifically fertilizer and 2 biostimulants. In addition, the system includes an energy recovery unit. Ultimately, slaughterhouse wastewater treatment facilities become biorefineries. The Water2Return demonstrator unit is installed at the Matadero del Sur in the civilian town of Salteras, Andalusia, Spain, treating 50 cubic meters of the daily flow of 150 cubic meters produced by the slaughterhouse, and can be a scalable and reproducible system according to user needs. The Water2Return system also represents a new business model within the framework of circular economy, opening up opportunities over several industries, such as water treatment, consultancy, distributors of agricultural and agronomic produce, amongst others.
Wonderful. Hope you all enjoyed the first video, and you're actually some of the first people to see this video. So it'll be available on YouTube shortly, but we wanted to show it to you first. Our second video will be an animated video, as mentioned earlier. It'll be in English, but with Spanish subtitles. And here we go.
In light of climate change, land limitation and soil degradation, there is a rising demand for alternative and sustainable solutions to maximize water use efficiency and to recover resources from going to waste. However, the European food industry, especially the slaughtering sector, has a high water and energy consumption, producing significantly large amounts of wastewater containing nutrients that end up being discarded. This results in serious environmental risks. So, what if we reverse this process and turn wastewater treatment facilities into nutrients biorefineries? The Horizon 2020 project, Water2Return, provides a cutting-edge solution for slaughterhouse wastewater treatment while recovering resources. It adopts a circular economy approach. The project's demonstrator is being run at the Matadero del Sur slaughterhouse premises in Salteras, a region well versed in water scarcity challenges. This integrated system not only treats wastewater but generates reclaimed water as well as energy, thanks to its energy recovery module. It also extracts resources to be further turned into high market value products for the agrochemical industry. Concretely, per each of its treatment lines, the system recovers 3 different secondary raw materials: nutrients, concentrate, hydrolyzed sludge, and algae biomass. These form the basis to further manufacture agronomic products, 1 biofertilizer and 2 biostimulants, ready to be used by the agricultural sector. This way, the Water2Return approach not only contributes to reducing the production of chemical fertilizers that may cause environmental problems, but also solves wastewater management issues in slaughterhouses while reducing water and energy costs at the same time. Water2Return's innovative, resource-oriented solution for industrial wastewater treatment is transposable to the needs of diverse industries and end users. It responds to a rising demand for sustainable alternatives, increasing water use efficiency and resource recovery, making it an optimal framework across Europe.
Hope you enjoyed those 2 videos. And the second video is already available on YouTube. In both, all videos are in English, but there's also subtitling in French, German, Italian, Portuguese, and Spanish. So if you want to share it with other people in the agricultural sector, the industrial sector, the political sector, policymakers, stakeholders, anyone you want, these are free videos. Of course, they're on YouTube, so you can share them and let people know about the project, let them know about the project outputs and how great it would work for their organizations. We are now going to move to the question and answer session. So if some of you, if you could turn on your monitors, sorry, your cameras. And I'm going to go to the questions. We'll start with the questions as we've received them in order. Also, be sure to add more questions because we love talking about the project, and you've joined us, so hopefully you enjoy listening to us talk about the project. So this one's a question for everyone. What are some of the biggest challenges you faced during the life cycle of the project? Water of the water.
I think I can reply because I already text my reply because I am very encouraged to give more details as long as you have questions. For the sustainability assessment, our biggest challenge was collecting the preliminary data. And as you've seen from my presentation, this kind of assessment requires a huge amount of data, and because we need to investigate the deepest connection with the final products. So, but it wasn't a big challenge. At the end, we overcome it with taking a preliminary data as well as the secondary data from the related databases. So I hope it would be useful.
Thank you.
Yeah. No, I was going to mention from talking about the project itself as a general issue. We have faced different kinds of difficulties, technical and non-technical. With regards to the non-technical ones, obviously, the pandemic has also been very, very, very hard with us because we had to come to Seville to install the different modules and so on, and therefore we have had to stop for a certain time. That is why we have also asked for an extension to the European Commission. So, I mean, but this is not a novelty because I guess everyone in their businesses have been blocked by this situation. And going into detail with regards to the technical point of view, I would highlight the fact that when checking I think David was explaining a little bit during his presentation, one of the main constraints we have faced is that when characterizing the wastewater coming from the slaughterhouse, we realized the amount of nitrogen and other nutrients was lower than initially expected. And this is something we cannot actually change. We have what we have, and this is what we have to treat and try to do the whole process. This means that with regards to the initial secondary raw material and agronomic product, the biofertilizer, the concentration was not enough to manufacture a commercially available product because of that, because of the amount of nutrients that the water, of nitrogen especially, the water actually had. So we can concentrate it as much as possible, but if the amount is low, then we can produce the fertilizer, but it cannot be commercially feasible. So this was, from the technical point of view, I think one of the bigger constraints, I think.
For us, for Kimitec, it was a different approach that we are used to. Usually, you want to develop a product with a specific goal. For example, increasing the flowering. Or in this case, we have the product, and we have to look for the utility, the most proper utility of this product. And this was the most difficult part for us, I think. Looking for the proper crop, the proper timing, and such thing. But we thought, I think we should say it. So.
Thank you, David. I'll say from my perspective, ELO perspective, we're involved with the policy briefs, and one of our the topics was we did a pest analysis examining the pros and cons of the political, economic, social, and technological points. We briefly addressed how it's EU should focus on having fertilizer coming from its within the EU rather than external sources. And this was written about 2 years ago, but as we've seen in the last month now, of course, that what was only hypothetical then has now become a reality. It's a large portion of the price increase in 2021, 200, I think 53%, 263%. So yeah, it's quite interesting seeing, having a change and having to update this these policies, because what we thought were only hypotheticals have now become actualities. So I think that was, for me, one of the most interesting or biggest challenges, is having to keep updating everything. We have another question. Near Seville, where the project was tested, it drops to 6 degrees Celsius in the winter. Would the system also work in more northern countries where it can sometimes drop below 0? If someone with more science background wants to address that.
Well, from my point of view, yes. I do not foresee any problem for the water line, the sludge line, and the energy recovery module. I'm not so sure about the algae line, because we need the algae growth, and for that the species would vary from one place to the other, and also sunlight is very important for the growth as well. So maybe for this concrete line, I'm not very technical regarding microalgae, but I think this could require a little bit more of adjustment. But the others, I would not say could be affected by different temperature. I don't know, David, if you know about this.
Yes, I have a little experience with microalgae, and in winter in the north of Europe it could be difficult to grow anything, but not during the other months. In this case, we just grow whatever it grows it's an open pound, so it's very difficult to select a strain and grow this specific strain. The approach we follow was to grow whatever it grows, and in every single country there are microalgae, but that's true. In winter in Poland it could be difficult to grow anything, but not in spring or summer.
Thank you, David. And now we have some highly technical questions from you, Laia. So I hope you're ready for this.
Okay.
Related to the FERTIMANURE project, is now being used in the project pilots. And what happens to the part of the manure that, after nutrient recovery, is left as an end product, i.e. not suitable for commercial processes? Does this need to be further treated before final disposal, or can it be returned to the fields directly? Thank you.
Okay, so in this case, FERTIMANURE is not willing to finish with the direct application of manure. So at the end, for farmers, manure application is the easier way to go forward, and it's not. So depending on the region where you are, it's still an option, and we are not willing to do that. So to finish with this, so our aim is to have alternative manure management strategies for those regions in which manure direct application is not allowed anymore. So at the end, now in the project, we have pilots with a TRL around 7. So of course we can, and only in 5 specific farms. So we cannot now say, okay, how, or the amount of manure treated in the project is not so relevant. And as I was saying, so the idea is not to finish with the direct application of manure is to have alternative management strategies to see how to do it safely, how to do it properly, and following the legal restrictions, and also to have a secondary source for obtaining the nutrients that for the fertilizing industry. So manure has lots of nutrients, and the idea is to see how we can recover these nutrients to have new business strategies, new nutrient sources, but it's not our aim to finish with the direct manure application, because if it's possible and it can be done safely, it's a good option for the farmers. So I'm not sure if I have answered the question, and if you want to know more specifically, I can answer it better.
Thank you very much. Yeah, if anyone has questions at the end, all the names and email addresses of all the participants here will be included, and you can contact them directly about either project. Another question, Laia. How is the controlling of heavy metals after the incineration of poultry manure? The question asker asks, supposes an ion exchange must be performed, and this can increase the production cost substantially. Do you have thoughts on this, or can you address it?
Yeah. So, well, in general, heavy metals are controlled in all the steps of our process. So we are controlling the heavy metals concentration in the different pilots and in the different products and intermediate steps to know where are going now the heavy metals. And I agree that the heavy metals content in the ashes, it's a challenge. And in our case, what we are doing with the ashes is extracting the phosphorus using acid extraction. That's how we have done it until now. We have not worked a lot with this yet. So, and we could see also if ion exchange could be an option. I agree also that this, depending on how the extraction is done, it can really change the costs of the process, but it will be accounted and considered in the life cycle costing that we will be doing, and also for the solid fraction of the for poultry in this case, or for the solid fraction of pig slurry in the Spanish pilot, we are not only considering this valorization route of incineration and recovery phosphorus from ashes, but we are also considering the option to finally obtain a peer-rich organic amendment in which the thermal process is not used. So, well, we will have the two scenarios, and we'll see which is the best one in terms of interest of the final product and also costs to obtain it.
Wonderful. And of course, your project does have close to 2 more years to complete, so it's in process, but we can't wait to see the results. This is, I believe, for a Water2REturn project. Generally speaking, what are the biggest barriers to adoption of this type of waste management system with other slaughterhouses in Europe? Is it money, local legislation, or presently not enough valorization by slaughterhouse owners? Pilar, would you like to address, or did you want me to address? Or just Giuseppe, are you able to address on behalf of slaughterhouse owners? I guess I can address some of it right now, and then Pilar can add her thoughts. Part of it is money. It's something that has an upfront cost and then savings long term. So people have to be willing to make that initial contribution and then have the results years down the line. It depends what portion of the what portion of the lines are included on the operation. I believe it was originally 2.5 to 7 years, depending what portions you use, but I'm sure Pilar has more up-to-date numbers. So yeah, that's definitely a key thing. Since it's just, the results have just been recently completed, the slaughterhouse owners still have to hear the results of the project, of which that's why we're attending today. So that's part of it. Local legislations. I mean, we knew all the past legislation and present legislation when making the project. So of course, everything was in line with that. And that's why we've been involved in making sure that future legislation recognizes the circular economy, recognizes the importance of these organic fertilizers. So, Pilar.
Oh, well, yes. Well, what we have realized, and during the proposals preparation stage and also during the project, when talking about slaughtering industry, they have to fulfill legal requirements to dispose their water. And for them, this concept of wastewater is basically something they have to get rid of, and it costs money to them. So what they want is basically to have as less cost as possible, fulfilling the current legislation. So it is important to highlight how this additional income by selling, for example, the secondary raw materials could support their business, because if not, for them is like an additional task, and it's complicated in this sense. As I was mentioning in the presentation, the current approach is fulfilling the legal requirements and dispose it, and that's all. And it is necessary to actually show them how this kind of approach can also provide them other revenues and other sources of income. What would be for them absolutely interesting, for example, if we focus not only on the secondary raw materials, but on the energy recovery issue, if this can help them to, for example, run the system, even if they do not get energy enough to run in the slaughterhouse, but at least for the system, that would be something really convenient. So it's something to work on with them.
Thank you. Yeah, just to reemphasize what Pilar said, this is waste that they would just pull out the nutrients and then have the clean water, but all that stuff would just be going to waste. Now we recognize the circular economy, how important it is to reuse these resources. So every portion of it, the sludge, the nutrients get pulled out, those become nutrients for fertilizer. The sludge is turned to algae biostimulants. The water is now clean to use. So slaughterhouse waste is now becoming a benefit because of this project. Another question for the Water2REturn project. What has been the benefit impact generated on the water savings? Who has benefited from it mostly? I know we've just done the pilot testing, so it hasn't been expanded too much, but are you able to answer that, Pilar?
Yeah, in this case, of course, there are different kinds of further uses we can give to the treated water. We have not focused on that within the project because we are treating 1/3 of the daily flow of the system. So what we actually do is mixing this treated water with the other 2/3, which have not been treated yet. So they are diluted and they are able to fulfill the disposal requirements. But in a further stage, it is possible to actually reuse the treated water within the slaughterhouse premises. It is important to take into account the current legislation for reclaimed water use, because it could not be used, for example, for cleaning any surfacing that could be in contact with products that could be further consumed by the people, even if the water is absolutely clean, let's say, but because of the current legislation, it could not touch surfaces in which meat is going to be there, but it could be used for cleaning the different kinds of corral, of the place in which the animals are. So this could be a further option to explore. And we would like to go on working on this sense if we have a further opportunity to go on working with the project.
Thank you very much, Pilar. Are there any other questions in the audience? Now's your chance. Otherwise, you can send us an email. I'll be putting my email in the chat. Also, just announcing on the 29th, we'll be doing a brokerage event It'll be a hybrid between Zoom and the Forum for the Future of Agriculture platform. You'll receive in your email in the following days how to log in. So if you want to get involved, if you want to be, you have greater questions about the project, we'll put you in contact with the right people. If you're a farmer, we'll explain how the fertilizers work. If you're in the industrial sector and you'd like to develop any of the lines at your plant, then we'll put you in contact with those people. So that'll be an email you'll receive soon. In terms of the greater event, this was part of, as mentioned, the Forum for the Future of Agriculture. The big event was last week, and this entire week will be solution workshops. I hope to see you at the upcoming events. For this project, I want to say how wonderful it's been working with everyone here for the last 5 years now. And it's good to have the project results. Once again, those project results will be available, water2return.eu. Most of them are already up. In the next weeks, the layman's report will come, so you can see a more less scientific explanation for those of us like me who are less scientific. Yes, let me just put into chat my email address. If you have any direct comments, you can let me know. For those in the audience, or sorry, those presenters, if you could turn on your cameras, we're going to take a screenshot. This has become very popular in these projects. 3, 2, 1. Excellent. Yeah, thank you, all our speakers, Pilar, David, Gulgan, Laia. Thank you for the staff in the background who've been working on this. Thank you, Marco. Had to leave. Giuseppe, pass on the message to Marco. And I think with that, unless anyone has any other comments, we will be concluding the event.